Good evening, class. We are looking at college algebra chapter 2, equations and inequalities, and here's section 2.4, complex numbers. So we are looking at complex numbers. We already have covered the rectangular coordinate systems, linear equations in one variable, models and applications, and here's complex numbers. So the objectives are add and subtract complex numbers, multiply and divide complex numbers, simplify powers of I, recognize a complex number, addition and subtraction, multiplication, conjugates and division, powers of I. So in short, we had the distance formula, we had the midpoint formula, a proportion, and the cross product, AD equals BC. Slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Lines are in the form of standard ax plus by equals c, slope intercept from y equals mx plus b, and point slope y minus y1 equals m times x minus x sub 1. Vertical lines x equals a, slope is undefined, x intercept at a0. Horizontal lines m equals 0, the y-intercept is at 0b, and equation is y equals b. Parallel lines, they have equal slopes, different y-intercepts. Perpendicular lines, the slopes is such that their product is -1, or you can say they are negative reciprocal of each other. So for example, m sub 2 is -1 over m sub 1, or you can say their product is -1. 2.4, complex numbers. An imaginary number is a number such as square root of -5. It is called imaginary because when imaginary numbers were first introduced, many mathematicians refused to believe they existed. That's the reason for their name. Imaginary unit, I, by definition, is square root of -1. How do we deal with the square root of a negative number? For any positive real number n, square root of -n, we cut it into two pieces, and we separate them into square root of -1 times n, and this is replaced by I. Complex numbers are numbers of the form a plus bi, where a and b are real numbers, and I is the imaginary unit. Every real number and every imaginary number are also complex numbers. The real part is a, the imaginary part is b, and the standard form of a complex number is a plus bi, a plus bi. So the synopsis of what we have here. We have whole numbers, 0, 1, 2, 3 to infinity. By the way, we also have natural numbers, which is without the 0, okay? They are also considered positive integers. Then we have then we have integers. We can go for both sides. We have rationals such as 1/2, -3/5, 9/4, any number that you can put it in the form of a fraction, where the top and the bottom are both integers, like decimals, repeating decimals, but something like square root of 2, square root of 3, pi, and so forth. These are non-repeating, non-terminating decimals. They're considered irrational numbers. The combination of the two in the form of a union gives rise to real numbers. And then we have non-real numbers, such as 2 plus 3i, 6 minus 4i, and so forth. And all of them are under the umbrella, the set of numbers called complex numbers, complex numbers. So again, quickly reminding you of the following. So we have natural numbers class, 0, 1, 2, continues indefinitely. Natural numbers, I mean, there is no 0. We have whole numbers, 0, 1, 2, 3. And then we have integers, 0, 1, 2 to infinity. We go to the negative side also. So I just wanted to make sure you understand this part, okay? All 4 operations can be performed on complex numbers. To do so, use the definition I equals square root of -1. And you square it, you get -1, and I give you more powers. Finally, I want to add this, so I'm going to erase this mess. The union of the set of all imaginary numbers and the set of all real numbers is the set of all complex numbers. So complex numbers covers everything. All right, so I is defined as square root of -1, and a plus bi is the standard form. So write each complex number in standard form. Here's example 1. Square root of -16 is the product of -1 and 16. -1, we get rid of it and we replace it with I. As you know, 16 comes out as 4. I times 4 or 4 times I. Either way is fine. Square root of -21, the same thing. It's the product of -1 and 21. So it's I square root of 21 or square root of 21 times I. One thing I want to make a point of, 21 can't come out, can't be simplified. You leave it like that. Because sometimes students may mix up whether or not I is under the radical. They put it in front of the square root of 21 sometimes. So you want to be careful of. So in short, negative under the radical, square root, okay? You replace it with I outside, okay? So this -1, we are going to replace it with the I outside. What about 32? You know, 32 is the product of 16 and 2, and 16 can come out as a 4. So we write it as a 4i square root of 2 or 4 square root of 2i. It's important to recognize this I is outside the square root. If we don't recognize that, we put it in between. That's why sometimes they put it in between to emphasize, be careful, I is not under the radical. How about square root of -9? This negative is replaced with I, and this 9 is replaced with 3. We can rewrite them first and then put it in this format. This negative, so negative square root of -48. This one remains, it doesn't go away. Now, this square root of -1, we can separate them and change them to I. And 48, you can do the factoring to figure out, or you can see you want to take out the largest, perfect square. The largest perfect square is 16 because this is 16 times 3. So this negative remains. This changes to I. This changes to 4. Minus I 4 square root of 3, or you may put the I in between. Okay. Now, what I want to show you, in case anybody has any problem with this number and how we ended up with that, you can do the factoring as follows. Everybody remembers prime numbers, right? 2, 3, 5, 7, 11, 13, 17, 19, continues indefinitely. So this is divisible by 2 because it ends up with 8. So 24, 2 again, 12, 2 again, 6, 2 again, 3. Now, when we get to 3, we can't divide it by 2 anymore. The next number is 3, and because we get 1, we are done. So in essence, what you're looking at is this. Square root of 48 is square root of 2 to the power of 4 times 3. And square root of 2 to the power of 4 can come out as 2 squared, square root of 3, and that's 4 square root of 3. So this is the part I'm referring to. Again, one way is to do prime factoring and simplify. All right, we add complex numbers just like we add polynomials by combining like terms. Okay. A plus bi, I is defined as square root of -1. The complex numbers obey the commutative, associative, and distributive laws. Thus, we can add and subtract them as we do binomials or just any polynomial. So it's pretty straightforward. I hope everybody is okay with that. Let's look at this example. We are adding up 9 plus 15i plus minus 6 minus 2i plus 18. Because this is a plus sign, when you distribute, nothing changes, so you don't have to worry about that. Let's put the numbers together and anything involving I together. So 9 and negative 6 and 18, we can put them together. 15i, negative 2i, we can put them together. So these three, 9 and negative 6, positive 3 and 18 is 21. And these two, they add up to 13i. Pretty straightforward. What about here? Again, since I see a plus sign, whether I distribute it or not makes no difference. I'm going to put the negative 9 and 6 together. And that results in negative 3. I'm going to put 6i and negative 13i together, and it ends up with negative 7i. So we have negative 3 minus 7i. However, because this is subtraction, we must distribute first. So we keep this as negative 3 plus 4i. This one becomes minus 4 plus 12i. Negative 3 and negative 4 gives us negative 7. And these two, 4i and 12i, they add up to 16i. So the final answer is minus 7 plus 16i. Multiply complex numbers. And here's example 3. Remember, a plus bi is the standard form. I equals square root of minus 1. And we want to multiply 8i by minus 4i. And so here's the process. Change all imaginary numbers to bi form, meaning if you have a negative under the radical, replace it with the I outside the radical. Multiply the complex numbers as you would multiply polynomials. Substitute negative 1 for I squared, because if I is square root of negative 1, then I squared becomes negative 1. Combine the real parts and imaginary parts. Write the answer in the form of A plus BI, A plus BI. So what do we have here? We have negative 32i squared. Very simple. Just imagine it's x minus 32x squared, the same thing. However, I is square root of negative 1 and I squared is negative 1. Let me write that. And so if we are replacing this one with negative 1, their product becomes positive 32. We are going to distribute everybody, and we get 18i minus 12i squared. Again, we're going to replace the I squared, just like this one, with negative 1. We get 18i plus 12. You can leave it like that, but it's really awkward to leave it like that. We are going to put it in the form of a plus bi, so the real part must be, first we write it as 12 plus 18i. If you didn't, it's not that big of a deal. All right. To do this, we are going to distribute. We are going to do foiling. So we're going to start with number 9. 9 times 3 is 27. 9 times I is 9i. Minus 4i times 3 is minus 12i. Minus 4i times I is negative 4i squared. So it's a simple foiling. Now, since I squared is negative 1, this changes to positive 4. So we can combine these two, 27 and 4, into 31. And these two to negative 3i. And that would be the final answer. Again, we're going to distribute, but let me remind you of the following. Everybody remembers a plus b times a minus b is a squared minus b squared. So if we have a squared plus a plus bi times a minus bi, we have a squared. Let me just tell you what we get, and then. So this one will give us a squared minus I squared b squared, and therefore a squared plus b squared. Remember that, use that. With that being the case, we're going to use this, become 7 squared plus 2 squared. 49 and 4, they add up to 53. All right, now we are going to multiply, and it is extremely important to pay attention that you can't multiply that the way you did with real numbers. First, this has to be changed to 2i, and this has to be changed to 3i, which gives you 6i squared, which is negative 6. However, if you just multiply it the way it is, it becomes 36. Square root of 36 is positive 6, which is a wrong answer. So this is the caution. You want to be extremely careful. So with that being the case, this is not what we want to do, okay? So for example, here, we're going to change this to, we're going to take this negative, get rid of it, and replace it with the I outside, the same thing with this guy. And now I and I is I squared. Now we can say 2 times 10 is 20. Now we're going to work on that. But now that this is a real number, okay, this was a real number, this was a real number, we multiply them. And 20, as you know, is the product of, you want two numbers, one should be a perfect square. As you know, this is 4 times 5. The 4 comes out as 2, the 5 remains, and I squared is replaced with a negative sign. So minus 2 square root of 5. We want this one, we are going to distribute. So 2i times 5, 10i. 2i times 3i is 6i squared. I squared is replaced by negative 1. We get 10i minus 6, and then we put it in standard form of a plus bi. We are going to distribute. So 2 times 4 gives us 8. 2 times negative 3i gives us negative 6i. I times 4 plus 4i. I times negative 3i minus 3i squared. So we're going to write all of those. And of course, we can add these two. And we are going to change this to plus 3 because I squared is negative 1. So we get 8 minus 2i plus 3, or 11 minus 2i. Yeah, pretty straightforward, everybody. Divide complex numbers. The conjugate of a complex number a plus bi is a minus bi. So in short, if you change the sign for one of these two becomes the conjugate, normally we do it for the second one. If you change both signs, becomes the opposite, but this is the conjugate. For example, 3 plus 7i, the conjugate is 3 minus 7i. 1 minus I squared of 3 is 1 plus I squared of 3. 2i, recognize it as 0 plus 2i. Therefore, it becomes minus 2i. Okay. You should know the answer is negative 2i. If it helps, change it to 0 plus 2i, the standard form, so you can see how it's done. Therefore, the concept of division, okay, we take to divide complex numbers, we take the following steps. Number one, change all imaginary numbers to bi form. So if you happen to have, for example, square root of minus 5, you say square root of 5i. That's the concept. Number two, multiply both numerator and denominator by the conjugate of the denominator. Finally, write the answer. Okay, write the answer in a plus bi form. This is in. If it's hard to see, let me just. Which is the standard form? The standard form a plus bi. So what do we mean by that? We are going to look at simple example to make some sense out of this. Starting with 7 over 3i. When you have just multiples of I, of course, the conjugate for that is negative 3i, but just multiplication by I will fix the problem. Okay, so we multiply by I and of course divide by I. When we do that, the top is clearly 7i. The bottom is 3i squared, which is negative 3, and that makes it negative 7/3 I. If anybody wants to write it in the form that was mentioned, it's 0 minus 7/3 I. The reason it's important to understand this, if somebody says what is A, or the real part is A, what is B, or the imaginary part, negative 7/3 third. So when the denominator is just I or multiples of I over I will do the job. So this will give us 9I plus I squared. The bottom is also I squared. And both of these I squared, we will change them to -1. And so what we have right here, this one is -9I, and this one is +1, and we put the 1 in front to put it in A plus BI form, the standard form of A plus BI. Now, this is different. As you can see, the bottom contains two terms, 5 minus I, so it has in the form of A plus BI. We need the A minus BI, which is the conjugate of that. So what is the conjugate of the denominator? 5 plus I. So we're going to multiply and divide by. By the way, again, the reason we do that, this is equal to 1, this is equal to 1, this is equal to 1, and it's acceptable. So must be equal to 1, otherwise it's not acceptable, okay? You can just multiply by any number you feel like it has to be in this manner. Now, first and foremost, I want to discuss the denominator because I hope you remember the denominator is 5 squared plus 1 squared because A is 5 and B in this case is -1, in this case is +1. It doesn't matter when you square it. So the bottom is 5 squared plus 1 squared. The top, you do the foiling. So to do the foiling, and I'm going to do it in this manner, 3 times 5 is 15. And then 3 times I is 3I, 5 times 5I is 25I. So the middle term is 28I. And this one is 5I squared. So in other words, do the foiling pretty fast for the sake of the reverse process later on when we look at the concept and reminding you of how we do factoring. Okay, so that's extremely important, everybody, okay? For now, it doesn't make that much of a difference. Of course, you know I squared is -1, so we're going to change this to -5. -5 and +15, they add up to +10. 28I doesn't change. 5 squared, let me just write that. As you know, this is 25. This is 1, they add up to 26. Now, it's important to write it in the standard form. Therefore, let's make up two fractions. This is 1, 10 over 26. This is another one, 28I over 26. As you know, they are both divisible by 2. This becomes 5 over 13. Same thing here. This becomes 14. This becomes 13I. When you write it in this format, if somebody says, okay, what is the value of A? You can answer it, 5 over 13. What is the value of B? Is 14 over 13. If you left it as this, you may not recognize that. And as always, dealing with the fractions, you put them in the lowest term. Lowest term. Powers of I, so as I mentioned, I squared of -1, then I squared is -1, I cubed is -I, and I to the power of 4 equals 1. The reason being is very simple, class. Let me just quickly show you. So this one is I squared times I, and we know I squared is -1, makes it -I. I to the power of 4, you can say, for example, I squared quantity squared, which is -1 quantity squared, and makes it 1. And therefore, I to the power of n moves in this fashion. it's -1. And this is I if it's 159, it's -1 if it's 2610, it's -I if it's 3711, and it's 1 if it's 4812. I'm not going to go with that. I'm going to show you an easier way to do that. Instead of memorizing this, I'm going to show you an easier way to do that. All you have to do, divide this exponent by number 4. Why number 4? Let me show you why number 4. Because we know I to the power of 4 is 1. So in this case, the answer is 10, remainder 0. You just keep the remainder. If the remainder is 0, which is the case here, it's the same as I to the power of 0, and it's 1. That's the fastest and easiest way. Another way of understanding that, it's I to the power of 4 to the power of 10. 1 to the power of 10 makes it 1. So again, shorter version. Divide by 4. Never mind the quotient, keep the remainder. Here's an example that will make it easy. If I want to do this, the way I will do that, class, I'm going to look at this number and say, okay, I'm going to divide 33 by 4. I get 8. 8 times 4 is 32, with the remainder 1. Therefore, this is I to the power of the remainder, or I. This is the way I do that. Or you can say I to the power of 4 is 1. 1 to the power of 8 is still 1 times I, and it's I. Give you one more example, because believe you me, if you follow this methodology, it's a lot easier. So I to the power of, let's say, 2002. If you divide 2002 by 4, remember, you don't even have to know what the answer is. Of course, it's 500 with the remainder 2. We just want the remainder. Remainder is 2. So this is the same as I squared. Now, what is I squared? -1. So the best course of action is to divide by 4, keep the remainder. All right. Well, it's explained in this example here. So 2002 divided by 4, the remainder is 2, and the answer is -1. So faster way, divide by 4, keep the remainder. How about 43? Let's quickly do that. We are going to divide number 43 by 4. The remainder, let me just write it here. Yeah, the remainder is 3. So this is I cubed, which is -I. 164 is divisible by 4, everybody. 164, if you divide it by 4, the remainder is 0. So this is equal to 1. Or you can say I to the power of 0, therefore 1. All right, to do this, first and foremost, we are going to make a change. 25 comes out as 5, square root of -1. The negative inside changes to 5. You must change it. 9 comes out as 3. This negative inside changes to I. So that's the first thing. So again, quickly, 2 and 4 don't change. 25 comes out as 5. Square root of -1 is replaced with I. 4 minus 9 comes out as 3. The negative inside changes to I. So again, just to make sure everybody is following that, I'm going to write next to it, this becomes 5I. This becomes 3I, and because we are dividing, we are going to multiply and divide by the conjugate of the denominator, which is 4 plus 3i. So we're going to multiply and divide by. Again, first, the denominator is simple. It's a squared plus b squared, so 4 squared plus 3 squared. And then we are going to do this. 2 times 4 is 8, 5i, and 3i is 15i squared. I just want to show you how we get to the middle term, just like the way we do with x. So 2 times 3i is 6i. 5i times 4i is 20i. Okay, can you see that? Let me just actually do it. So the product of these two is 20i, and they add up to 26i. So again, a quick recap. Let me erase the mess and show you what I meant. So 2 times 4 is 8. 2 times 3i, 6i. 5i times 4, 20i. They add up to 26i. And the last one's 15i squared. 4 squared plus 3 squared. Now, of course, this is 16, this is 9, this is minus 15, okay? So 8 and minus 15, they add up to negative 7, and the bottom 16 and 9, 25. It's a good practice to separate them into 1 and 2 fractions, because now we can clearly answer the value of A is minus 7 over 25, the value of B is 26 over 25. Is x equals 2 minus I a solution of this function? Remember, if you're checking to see something is a solution, all you have to do, plug in. So if I plug in 2 minus I, let's see what happens. So we're going to say 2 minus I squared minus 4 times 2 minus I plus 5. Is that going to be equal to 0? That's what we are checking. Okay. So one more time. 2 minus I quantity squared minus 4 times 2 minus I plus 5. Do we get to 0? We'll find out in a moment. We're going to square that. Again, a minus b quantity squared. Everybody remembers that. It's a squared, so 2 squared or 4 minus 2 times 2, 4i, and then plus I squared. That's this part. Okay, everybody. And then minus 8 plus 4i plus 5. As you can see here, this is minus 1, negative 4i, positive 4i cancel each other. 4, negative 8, negative 4, plus 5, minus 1. They all add up to 0. The answer is yes. So I hope you see that it actually works. And you have to show work class, okay? You have to show that both sides end up being 0. That's how you show your work, everybody. You have to show that both sides end up being 0. So as you can see, when we add them up, this is what we get. And that's done. All right, we're going to move on, everybody. All right, we're going to continue with operations, in this case, add or subtract or simplify. And basically, we are going to put these two together and put these two together. That's the idea, everybody. 3 and 7 adds up to 10. 2i and 8i, they add up to 10i. For part B, you have to distribute the negative sign before you can move on. So we keep the first parenthesis as 10 minus 9, and then we change that to minus 9 minus I. Therefore, we can put the 10, negative 9 together. We get 10 minus 9. We can also put negative 2i and negative I together, combining like terms. So this is 1. This is negative 3i. This is, again, one way to do that. All right, we are dividing, and I said whenever the denominator is just I or multiples of I, multiply and divide by I. When you do that, clearly the bottom becomes I squared, and the top becomes 3i plus 2i squared. 2i squared means negative 2, I squared means negative 1. And so we are looking at 3i over negative 1 or minus 3i, and negative 2 over negative 1 or positive 2, and we put it in standard form by putting a first. So a is 2, a is 2, and b is negative 3, a plus bi. In this case, we multiply by the conjugate of the denominator and we divide by it. So 2 plus 3i we need for the top, and the bottom, again, this fraction is nothing but 1. First, I'm going to explain the bottom again because it's easy. It's a squared plus b squared. Remember that because they are complex numbers. So 2 squared plus 3 squared. What happens to the top? Voiding. 4 times 2, 4 times 3i, I times 2, I times 3i. Of course, these two class, we should be able to do it actually together. In other words, these two and these two. Okay, so clearly these two add up to 14i. 3i squared is replaced with negative 3, and negative 9i squared is replaced with positive 9 because I squared is negative 1, as you know. So what we are looking at here is 8 and negative 3. They add up to 5, and 12i and 12i, they add up to, and 2i, they add up to 14i. 4 and 9, they add up to 13. Now we make up two fractions. This is one of them, 5 over 13. And this is another one, 14 over 13 times I. So if somebody asks, okay, you put it in standard form, what is A? 5 over 13. What is B? 14 over 13, meaning the real part is 5 over 13 and the imaginary part is 14 over 13. Let me go over this concept of a complex number again. Z equals x plus yi, where x and y are real numbers and I is square root of negative 1 is an imaginary number. The magnitude or modulus of z is the distance from the origin to the point x comma y, which follows the Pythagorean theorem. We call it r, or square root of x squared plus y squared. So I want to give you a little deeper meaning of this. So if you were to look at the concept of a complex plane, they go with the x-axis and they call it the real axis. They go with the y-axis and they call it imaginary axis. This angle is theta. This distance is the modulus of z, or the magnitude, which is r, and it follows that it's x squared plus y squared. Okay, a couple of things in case for the future if it comes up. So this represents the magnitude which follows the Pythagorean theorem, and it's equal to the product of z bar under the radical. Z bar, z is x plus yi or a plus bi, and z bar is its conjugate. Some basics from trigonometry in case you don't have to worry about that, but x, this distance is r cosine theta, and y, this distance is r sine theta. Okay, and it is used r cosine theta plus ir sine theta, they call it r cis theta. In case anybody has seen this before, I don't want you to worry about this at all. All I want you to see is the following. How would you plot the complex number 2 plus 2i and then 1 minus 2i? I want to just quickly show you how easy it is. If somebody asks you to plot that, you should have absolutely no problem whatsoever. It's very simple. This is 2 plus 2i. So go 2 along the x-axis, we're going to call it the real axis, and go 2 along the y-axis, we're going to call it imaginary axis. This is 2, this is 2, put them together. So that's it. It's just like basic rectangular coordinate system. 1 minus 2i, 1, go 1 along the x-axis. Again, we're going to call it the real axis. Go minus 2 along the y-axis. That means go down along the y-axis, which we're going to call it the imaginary axis. So here's 1, here's negative 2, put them together, and it gives you this point. So all we have to do, can we plot those easy points? That's the question, and we should be able to do that.